This is a short video demoing traverse line mode for the RIM software, the RIM UI. Again, we know that we're in this mode if this says current mode, traverse line mode. If not, you can select it through the mode select dropdown. And once you select it, you'll see this window here be lit up. So what this mode allows us to do is it allows us to enter in a position and orientation to go to, right now just position, in Cartesian coordinates, and then you can tell the arm to go there and see if the arm actually goes there. So for example, let's say I want to move to a position of 250 millimeters, and then maybe negative 250 in Y, and then let's say 500 in Z. So you can see in the top right of the video that there's a coordinate system set up for the arm. Y is to the right, positive Y. Positive X is towards the camera, and positive Z is straight up. So I'm going to click check calculation, and it says it's passed. And so what it just did is it did a whole bunch of math to figure out how it needs to move its 6 motors, the 6 joints, in order to get to this position. So now I'll go ahead and click start. And now it's going to move the arm's end effector to that location. And so I told it to go to positive 250x, negative 250y. So that's towards the camera, and then y is to the left, and then positive 500z. So, and that's from the table. So that's 500. And we can check this because each joint has what's called an encoder, and these encoders track the rotational position of each joint. And from that, we're able to use forward kinematics, which is talked about in another part of our website, to figure out where the end effector is located. And so I'm going to click this, and it says we're at 250x, 248y, and 498z. Now it's a little off, so I'm going to go ahead and do this calculation again and click start again. And the arm did some micro adjustments there, and I'll click again, and now we're at 249.9, 249.3, and 499.1. So we're closer to our target position. So this is something that we used when we were testing positional accuracy. We'd tell the arm to go to a point, and we'd do that 20 times and see how repeatably we could approach a point and how accurately. So let's do another example. Let's say I want to move to a position similar to the picture in the top right. So that has a negative x. So let's put in negative, 370 millimeters. And then it's got a positive y, so we'll do positive 370 there, just like that. And then it's got also a positive z, so we'll try 450, see if that works. Now, this calculation will fail if the point that you tell it to go to is out of bounds for the arm. So I'll calculate, it passed, so I'll go ahead and click start. Now the arm's going to do the math and figure out how to get to that position, which should look somewhat like the picture in the top right. There you go. And then I can click this to check, and it says we're at negative 369, 372, and 449. So I'll go ahead and do some micro adjustments again. Check again. Now we're at 370, 370, 449. So pretty close. And yeah, that's how traverse line mode works.